today's video, we'll be discussing about Physics Paper 1 MCQ Paper 2024 May June Variant is 12 and the subject code is 9702. 1. What is a scalar quantity? So a scalar quantity is a quantity that have magnitude only, while a vector quantity is a quantity that have both magnitude and direction. So a scalar quantity is a quantity without direction, that means it has magnitude only without direction. So the answer is C. 2. The value of quantity x has a percentage uncertainty of 2%. The value of quantity y has a percentage uncertainty of 4%. The value of quantity w is calculated from the values of x and y. The value of w has a percentage uncertainty of 8%. What could be the relationship between w, x and y? So if w is equal to xy, then percentage uncertainty in x plus percentage uncertainty in y is equal to percentage uncertainty in w. So here we can see that if we add the percentage uncertainty, that is 2 plus 4 is equal to 6%, which is not equal to 8%. Therefore, the option A is wrong. Then for the option B, again, percentage uncertainty in x plus percentage uncertainty in y. And 2 is a constant, so it has no effect. So it again comes to be 6%, therefore it is wrong. It is not 8%. Then percentage uncertainty in x plus whether it is divided or multiplied, the percentage uncertainties are always added. So percentage uncertainty in x plus 2 into percentage uncertainty in y. Since it is y square, so 2 into percentage uncertainty in y. So after calculating, we get a value of 10%. That is not equal to 8%. Therefore, this is wrong. Then w is equal to y by x square. That is percentage uncertainty in y plus 2 into percentage uncertainty in x. So after calculating the value, we get a value of 8%. So yes, it is equal to 8%. So this relationship is valid. So the answer is D. Number 3. A football is kicked so that it moves vertically upwards through the air. So this is our football and it is kicked so that it moves vertically upwards. What is the variation of air resistance and the resultant force acting on the ball as it moves vertically upwards? So what is the variation of air resistance and the resultant force? So for this ball, the weight is acting vertically downwards. And since the object is moving upward, so the air resistance is obviously acting downward. So the object is moving upward and the air resistance is acting downwards. And initially it has a velocity of v. And as it moves upward, it comes to a point where the velocity becomes zero, and the ball then again moves downwards. So we can see that the velocity decreases as the ball is moving upward. Since the velocity decreases, so the air resistance also decreases. Because we know that air resistance depends on velocity, so if the velocity decreases, air resistance decreases. If the velocity increases, then air resistance also increases. But for now, the velocity decreases, so the velocity decreases until it comes to 0. Therefore, the air resistance also decreases. So air resistance decreases and decreases. So air resistance decreases, and we know that resultant force is equal to weight plus air resistance. So resultant force is equal to weight plus air resistance, and as air resistance decreases, the resultant force, we can see that the resultant force also decreases. So it must decrease. 4. Which statement is not correct? So acceleration can be determined from the gradient of the velocity time graph. So for the velocity time graph, the gradient of the velocity time graph is acceleration. So this statement is correct, but we need to pick a wrong statement. Acceleration is equal to, or acceleration is the rate of change in velocity. So acceleration is equal to change in velocity by change in time. That is the rate of change in velocity. Again, this statement is correct. Then displacement can be determined from the area under the velocity time graph. So area under the velocity time graph is the displacement. So this statement is also correct, and we need to pick the wrong statement. Velocity is the rate of change of distance. This statement is wrong because velocity is the rate of change of displacement, not the distance. So the wrong answer, or the not correct answer, is D. Number 5. The diagram shows a laboratory experiment in which a feather falls from rest. So it is falling from rest in a long evacuated vertical tube of length L. So it is falling from rest, that is initial speed is 0. The feather takes time t to fall from the top to the bottom of the tube. So from the top to the bottom it takes time t. How far does the feather fall from the top of the tube in a time of 0.50 0.50 t. So we have given the value of time and we need to find how far the feather falls from the top. So we define this distance or the displacement from the top as x. Now by using the equation, s is equal to ut plus half at square. So for the first condition, that is when it is following the total length, so total length is L is equal to ut and U is 0. So 0 into t plus half. Acceleration value is not given, so we refer this as a, and t square. So t square is t square. So here we have given the value of time, that is for the total length L is capital T. So this is the expression for the L. And now for the smaller distance, that is in 0.50 t. So we refer the distance or the displacement as x. So x is equal to ut. Initial speed is 0. So 0 into t. And the time is 0.5 t plus half a and t square. So 0.50 t square. So the expression comes to be 0.125 a t square. So this is the expression for x in terms of a and t. Now we need to find the x value, that is a displacement value with respect to L. That means we need to substitute at square in the expression. So we need to substitute L in this expression. So we need to make at square becomes the subjective formula. So if we solve this equation, then 2L is equal to at square. So at square is equal to 2L. This is our expression 1. Now we substitute this expression in this expression, that is at square. Instead of at square, we write this as 2L. So 0.125, and instead of at square, we substitute 2L. So the value of x comes to be 0.25L. So 0.25L, that is answer B. 6. A car travels along a straight horizontal road. The graph shows the variation of velocity of the car with time t for 6 seconds of its journey. So velocity against time graph. This is the velocity against time graph. The brake of the car are applied from time 1 to time 4. So from time t is equal to 1 to time t is equal to 4, the brake is applied. So brakes are applied. How far does the car travel while the brakes are applied? Now we need to find how far the car travels. So the displacement the car travels when the brakes are applied. So brakes are applied between 1 and 4 seconds, that is in this time period. So the brakes are applied in this time period. So we need to find how far the car travel or the displacement. And we know that area under the velocity time graph is displacement. So displacement is equal to area under the velocity time graph, that is the area of the trapezium. So half into sum of two parallel sides, and the parallel sides are this length 22 and this vertical length, that is 8. So half into sum of two parallel sides into height, and the height is 4 minus 1, that is 3. So after solving, we get the displacement as 45 meter, and the displacement is the area under the velocity time graph, which is 45 meter. 7. Two satellites in deep space collide inelastically. So the satellites collide inelastically. What happens to the kinetic energy and the total momentum? Total kinetic energy and total momentum. So total kinetic energy and total momentum. So for inelastic collision, we know that momentum is always conserved, whether it is an elastic collision or an inelastic collision. So momentum is always conserved. But since it is not an elastic collision, so kinetic energy is not conserved, and relative speed of approach is not equal to relative speed of separation. And for relative speed of approach is equal to relative speed of separation, we know that u1 plus v1 is equal to u2 plus v2. So since it is an inelastic collision, so relative speed of approach is not equal to relative speed of separation, and kinetic energy is not conserved. So it is not conserved or it is reduced. So the correct answer would be C. 8. What is a reasonable estimate of the momentum of a family car traveling at 25 kilometers per hour? So we need to find the momentum, and here we have given the values as kilogram meter per second. So that means we need to convert kilometer per hour to meter per second. So 25 kilometer per hour, that is 25 into 1000 meter, by hour. So we need to convert the hour to second. That is, the answers are all given to second. That is, 1 hour is equal to 60 minutes into 60 seconds. So this is our value in meter per second. That is the speed. Now, what is the momentum? We know that momentum is equal to mass into velocity. So we know the value of velocity. But what is the mass? So the mass of a family car is usually 1000 kilogram to 1000 kilogram to 2000 kilogram. So here we substitute the value of mass. Since it is an estimate, so it is an estimate. That is, we substitute our estimated value of mass and find the value of momentum as 7 into 10 to the power 3. So 10 to the power 3 is close to 1 into 10 to the power 4. So the answer is A. 9. A ball collides with a wall. Before the collision, the ball moves with velocity 8 meter per second. So before collision, it moves with a velocity of 8 meter per second towards the right. So right after collision, it moves with a velocity of 3 meter per second to the left. So if we consider the right as positive, that is the right as positive, then the left is negative. If we consider the right as positive, then the left is negative. That means the velocity towards the right as positive, while the velocity towards the left as negative. So after the collision, its velocity is negative 3 meter per second. What is the change in velocity of the ball during the collision? So change in velocity is equal to final velocity minus initial velocity, and final velocity is negative 3 meter per second minus the initial velocity. So initial velocity is 8 meter per second. So we get a value that is negative 11 meter per second. So 11 meter per second and 11 meter per second. And since it is negative, that means the ball is moving towards the left. So the answer is C. 10. A lead pellet is shot vertically upwards into a clay block that is stationary at the moment of impact but is able to rise freely after the impact. The mass of the pellet is 5 gram and the mass of the clay block is 95 gram. The pellet hits the block with an initial vertical velocity of 200 meter per second. It embeds itself into the block and does not emerge. How high above the initial position will the block rise? So initially, if this is our block, then it is stationary and the pellet hits the block with 200 meter per second. After the impact, the pellet embeds itself into the block and they move together. So it embeds itself, that means it does not move apart and they together move with a speed v. And now we need to find the speed v. So first of all, we need to find the speed v, that is the total speed after the impact. So mass, that is 5 gram, into the velocity, that is 200 meter per second of the pellet, plus since the stationary block is stationary, so its velocity is 0 and mass is 95, is equal to, after the impact, that is after the impact it embeds itself, that is the total masses are added since they together move up together. So the together mass is 100 gram, that is 95 plus 5, that is 100 gram, and they move up with a velocity v. So v, since both are in gram, so they would cancel. And the velocity comes to be 10 meter per second. That means the initial velocity is 10 meter per second, by which they move upwards. And they come to a point where the velocity is 0. That means the velocity of the pellet and the block is 0. And we need to find this height from its initial position. That is, at the topmost point, the velocity is 0. And we need to find this height. So at the topmost point the velocity is 0 and then again they move downwards. So we need to find the height above the ground they rises. So regarding the information, we know the initial velocity, that is u is equal to 10 meter per second, that is 10 meter per second. Final velocity is 0 meter per second. Since they come to rest at the topmost point, then acceleration of free fall is 9.81 meter per second square. So we know the acceleration, initial speed and the final speed. And we need to find the height above its initial position, that is distance s. So s. So s, a, u and v. So we can use the formula v square minus u square is equal to 2s to solve this problem. So v square minus u square is equal to 2s, where v is the final velocity, u is the initial velocity, 2as. After solving this, we get the distance that is moved upwards is 5.096 or approximately 5.1 meter. So the answer is A. Two forces act on an object. Which diagram represents a couple? So a couple consists of two forces of equal magnitude but acts in opposite direction whose line of action do not coincide. So two forces of equal magnitude, so they are not equal magnitude. but act in opposite direction, so they are not acting in opposite direction, and whose line of action do not coincide. That means this is the line of action of this force, while this is the line of action of this force, so they do not coincide. Coincide means like this, that the two forces are from the same point, so the line of action do not coincide. And the torque of a couple is the product of one of the forces and the distance between the forces, that is the product of one of the forces and the distance between the two forces, that is d. So this is the torque of a couple or the moment of a couple. 12. The diagram shows a uniform rod XY that is freely hinged to a vertical wall at the end Y. The rod is at an angle of 60 degree to the wall. A force F acts at an angle of 30 degree to the rod at the end X. So force F acts at an angle of 30 degree. The rod has a weight of 3 Newton and is in equilibrium. So the rod has a weight of 3 Newton, that is vertically downward, and the rod is in equilibrium. That means at equilibrium we know that the resultant force is 0 and the resultant moment is 0. So you need to remember that at equilibrium the resultant force is 0 and the resultant moment is 0. Since the rod is in equilibrium, so the resultant force and the resultant moment on the rod is 0. What is the magnitude of force F? So we need to find the magnitude of force F. So this force is acting at an angle, so we need to find the horizontal and the vertical component of this force. That is the F cos 30 and F sin 30 and 3 Newton. So we need to find its horizontal and the vertical component of the forces with respective to this rod. So 3 cos 30 and this side would be 3 sin 30. So now we have found the forces. Now the magnitude of force F. To find the magnitude of force, we know that the upward moment is equal to downward moment, and we know that moment of force is the product of force and the perpendicular distance from the pivot to the line of action of force. So from the pivot to the line of action of force, we need to find this perpendicular distance. That is this perpendicular distance, since the force is acting from this point. So this distance we refer as d. And since the weight is acting from the center of the rod, since it is an uniform rod, so the weight is acting at the center. That means if the total distance is d, then this distance would be d by 2. Since it is acting at the center, so it is divided by 2. And 3 cos 30, that is the vertical force and the distance. So after calculating, we get the value of F as 2.59 Newton, that is 2.6 Newton. In question number 13, water has a density of 1 gram per centimeter cube. Glycerin has a density of 1.3 gram per centimeter cube. A student measures out a volume of 40 cm cube of glycerin into a container. The student adds water to the container to make a mixture of water and glycerin. Assume that the total volume of water and glycerin does not change when the two liquids are mixed. Which volume of water needs to be added to make a mixture of density given? So we need to find the volume of water that is being added. So first of all, we need to know the density is equal to mass by volume. So we have given the value of total density. So the total density of the combined density is 1.1. So total density is equal to total mass by total volume. And we know the value of total density. So what is the total mass? So total mass of water plus total mass of glycerin by the total volume of water plus total volume of glycerin. So total density is equal to total mass by total volume. And for the mass of water, so we know the value of density of water. So what is the mass of water? So mass is equal to density into volume. That is, we multiply density with its volume that we consider as VW. So we multiply density with the VW to find the mass in terms of V. So we find the mass. Then the mass of glycerin. What is the mass of glycerin? So we know the density of glycerin and the volume of glycerin. So mass is equal to density into volume. So this is the mass of glycerin, that is 52. So 52, this is 52, and this would be in gram, by volume of water plus volume of glycerin, which is given, that is the volume of glycerin is 40 cm of glycerin. So after calculating, we multiply this with this term. So 1.1 W plus this term is equal to this. Then after solving, we get the value of volume of water as 80 cm cube. So the volume of water is 80 cm cube. 14. The force resisting the motion of a car is proportional to the square of the car's speed. So the force resisting the motion is proportional to the square of the speed. The magnitude of the force at a speed of 20 meter per second is 800 Newton. So when the speed is 20, the force is 800. What is the useful power output required for the car's engine to maintain a steady speed of 40 meter per second? So we need to find the power output, and we know that power is equal to force into velocity, or power is equal to driving force into velocity. So power is equal to driving force into velocity, and suppose this is the car and this is the driving force and this is the resistive force. So we have given an expression in terms of the resistive force, so it is R. So the resistive force. Now here we have given that the car maintains a steady speed. So we know that at steady speed or at a constant speed, the resultant force is 0. Since the resultant force is 0, that means the forward force must equal to the backward force. So if we just found the resistive force, then we can easily found the driving force, since at steady speed driving force is equal to resistive force. So what is the resistive force? So we know that resistive force is directly proportional to V square, or resistive force is equal to kV square, or we can write this in terms of ratio, that is R1 by R2 by V1 by V2, V1 square by V2 square. So we can use either of this expression, but the most convenient one is this one. So we know the value of R1. So the value of R1, that is 800 by R2, we need to find this resistive force, that is R2, is equal to V1, that is 20 square by 40 square. So R2, we get the value of 3200 Newton. That is the resistive force. Since we know the value of resistive force, that is equal to the driving force at steady speed. So we know the value of driving force and we know the velocity, that is 40. So after calculating, we get this power, that is 128 kilowatt. So the answer is C, 128 kilowatt. A block of weight W is pulled by a force P along a slope. So this is the force P that is acting on the block. The length of the slope is d and the block rises a height h. So this is the height and this is the length of the slope. The frictional force between the block and the slope is F. The diagram shows the direction of the forces. The purpose of the slope is to raise the block vertically. So mainly we need to raise the block vertically. Which expression gives the efficiency of the slope? So efficiency is equal to useful energy by total energy. So useful energy by total energy. So to find the value of efficiency, first of all, we need to find the total energy that we input. So total energy input is equal to, so energy or work, both are the same. So useful energy or useful work, total energy or total work. So we know that work done is equal to driving force into distance. So this is our driving force, that is P. So driving force and the distance is D. So work done is equal to force into distance, that is P into D. So this is our driving force into distance. That is our total work. So total work that we input. And what is the work output or the energy output? So our aim is to raise the block vertically. So mainly our useful work output is the vertical height covered by the block. So what is the vertical height covered by the block? So energy output is equal to gravitational potential energy. That is since we need to raise the block vertically, so basically we supplied the block gravitational potential energy. So gravitational potential energy is equal to mass into gravitational field strength into height, and mass into gravitational field strength is weight into height. So this is our energy output. So energy output by total energy input into 100%, but it is not mentioned that the 100%, so we can ignore this. So WH by PD. So WH by PD is the efficiency. 16. The kinetic energy of a particle is increased by a factor of 4. By what factor does its speed increases? So let's suppose the initial kinetic energy is Ek, and after increasing by a factor of 4, it increases by a factor of 4. So 4 times the initial kinetic energy. And initial speed we consider as V, and after increasing by a factor of 4, the speed we consider is V2. So we know that kinetic energy is equal to half mv square. So half is constant, mass is same. So kinetic energy is directly proportional to V square. So by using this relationship, we can write kinetic energy is equal to kV square, or kinetic energy 1 by kinetic energy 2 is equal to V square 1 by V square 2. So we know the value of kinetic energy, that is the initial kinetic energy, and after increasing by a factor of 4 the kinetic energy, V square, that is the initial V square, and 2V square. So what is the value of 2V or V2? So V2 after, so kinetic energy and kinetic energy cancels, and V square is multiplied by 4, so 4V square is equal to V2 square. So what is the value of V2? Is equal to, V2 is equal to root over 4V square, that is 2V square, 2V. So the final velocity, that is 2V, and V is the initial velocity, and V2 is equal to 2V. That means our velocity increases by a factor of 2. So it is increasing by a factor of 2. 17. A mass of 28 gram is raised vertically upward. So it rises vertically upward, vertical, through a distance of 4.6 meter. So the vertical height is 4.6 meter. What is the change in gravitational potential energy of the mass? So gravitational potential energy is equal to mass into gravitational velocity into height. That is, we need to convert the mass to kilogram, and the gravitational velocity is 9.81 and the height is 4.6 meter. So the gravitational potential energy comes to be 1.26 joule, that is 1.3 joules. Question number 18. A sample of metal is subjected to a force which increases to a maximum value and then decreases back to zero. The force extension graph for the sample is shown. When the sample contracts, it follows the same force extension curve as when it was being stretched. What is the behavior of the metal between x and y? So when the sample contracts, it follows the same force extension curve. So it follows the same force extension curve. That means it returns to an extension that is 0. What is the behavior of the metal between x and y? So is it elastic deformation or is it plastic deformation? So here we can see that it returns to an extension of 0. Since the extension is 0, so it is obviously an elastic deformation and it is not a plastic deformation. Since the extension returns to 0, so it is obviously an elastic deformation, it is not plastic. 19. Two wires P and Q made of the same material are stretched with an increasing force. A graph is plotted of the variation of force of the extension of each wire. The wires have the same original length L but different diameters. What is the ratio of diameter of wire Q by diameter of wire P? So we need to find the ratio of diameter, and since they are made of the same material, so both have the same Young modulus. So they have the same Young modulus and they have the same original length. Now we know that Young modulus is equal to force per unit area extension divided by original length. So here we have given that the wires are made of the same material, so they have the same Young modulus. Then we can see that for both the wires P and Q, the total force is 2 Newton. So the force is also same. So force is also same. Then the original length is also same, that is L. Now, since all of these are same, and we need to relate diameter with extension since they have different extension. So after making the diameter becomes the subject of formula, so first of all, here we need to convert area to diameter, that is area is equal to pi d square by 4. So now we need to make diameter becomes the subject of formula, that is d square is equal to 4 FL by E, that is a Young modulus pi x. And we know that force is same, force is also same, length is also same for both the wires, Young modulus is same since they are made of the same material, and pi is same. So basically here we can see that diameter square is inversely proportional to x. So diameter square is inversely proportional to x. That means diameter of q square by diameter of p square is equal to the extension of q by extension of p, since they are inversely proportional. So diameter square of q by diameter square of p is equal to extension of p by extension of q. And so we need to find the ratio of diameter of q by diameter of p. That is, we need to take square root on both the sides to cancel the square. So diameter of q by diameter of p is equal to square root of extension of p by extension of q. So square root of extension of p. So we need to convert extension in terms of meter, or if it is the ratio, then as it is the ratio, so the units would cancel. So whether we convert to meter or millimeter, it would be the same. So extension of p is 3 and the extension of q is 1. So root over 3. So the diameter of q by diameter of p comes to root over 3. That is an extension force graph for a spring is shown. So extension against force graph. What is the spring constant of the spring? So we know that spring constant is equal to force by extension. So force is 6 Newton, and we need to convert the extension to meter. So 15 by 100 meter. So the spring constant comes to 40 Newton per meter. That is 21. A man stands stationary in front of a swing. A child sits and swings. The child blows a whistle that emits a sound at constant frequency. The man observes the frequency of the sound when the swing is at position x, y, and z. When will the man hear the highest frequency? So when will the man hears the highest frequency? That is, the observed frequency is highest. So we know that Fo is equal to Fsv, V plus minus Vs. So by using this formula, we know that when the object is moving towards the observer, the observed frequency is more, and when the object is moving away from the observed frequency is less. So when it moves towards the observed frequency is more. Since the observed frequency is more, so the denominator would be less. And when the object is moving away from the observed frequency would be less. Since the observed frequency is less, so the denominator would be more. That is, it has a plus sign at the denominator. So regarding the options, when the swing has position x, and when the swing is at position z, so x and z. So when the swing is at x, it comes momentarily to rest. So when the swing is at position x, it comes momentarily to rest. Therefore here velocity is 0. That is, the velocity of the source is 0. Vs is 0. Also, when the swing is at position z, it comes to momentary rest before going again to point y. Therefore here it is also momentarily at rest, so the velocity of the source is 0. Since the velocity of the source is 0 at these points, so for the highest frequency, that is, the object is moving towards the observer, because when it is moving away, the observed frequency is less. So we need to get the highest frequency when the object is moving towards the observer, because when it is moving towards, the frequency is the highest. So by using this formula, at point x and z, if the Vs is 0, if the velocity of the source is 0, that means it is minus 0, then we can see that the denominator value would be more compared to it is V minus Vs when it has a value, suppose it has a value of 2. So here we can see that when the denominator has a value of 2, then V minus 2 has a less value, while here we can see that V minus 0 has a value of V. So it has a less value since the denominator is less at this point, so the observed frequency is more. But when it has a speed of 0, so we can get a large frequency, therefore it is wrong. Therefore these options are wrong. When the swing is at position y and is moving away from the man, so at point y and is moving away. Since it is moving away, so it would be V plus Vs, so the denominator would be more, so the observed frequency is less. Therefore this option is wrong. But when the swing is at position y and is moving towards the man, so at point y, and the swing is moving towards the man. Since it is moving towards the man, so V minus Vs, and due to this, the denominator would be less, so the observed frequency would be more. So the answer would be C. Where we to a loudspeaker is playing music in a room. The door to the room is open and has a width of 0.80 meter. So suppose this is the door and it has a width of 0.80 meter. Sound waves of many different frequencies pass through the doorway and diffract. The speed of the sound in air is 340 meter per second. Which frequency of sound wave diffracts the most as it passes through the doorway? So diffracts the more. That means the highest diffraction. And we know that the highest diffraction occurs when the wavelength is approximately equal to the width of the gap. So the highest diffraction occurs when wavelength is approximately equal to the width of the gap. Suppose the width of the gap is this much, so the wavelength is approximately this much. So here we can see that the wavelength is approximately equal to the width of the gap. Wavelength is approximately equal to the width of the gap, so the diffraction is the highest. And we need to find the highest diffraction. So for this, we consider the width of the gap as the wavelength. That is, it is equal to the wavelength. So we would get a highest diffraction. And V is equal to F lambda by using this formula. F is equal to V by lambda. So V by the wavelength. So we get a frequency that is 425 or approximately 4.3 into 10 to the power 2. It would be 10 to the power 2 Hz. So the answer For question number 23, the stationary sound wave is set up between a loudspeaker and a wall. So, stationary sound wave is set up between a loudspeaker. So, let's suppose this is our loudspeaker and this is the wall, and in between the loudspeaker and the wall, the stationary wave is set up. A microphone is connected to a cathode oscilloscope, is moved along a line directly between the loudspeaker and the wall. So, suppose this is our microphone. This is a microphone. This mic is connected and is moved between the speaker and the wall. The amplitude of the trace on the CRO rises to the maximum at position X. So at position X, let's suppose this is the position X and it is maximum at position X and falls to a minimum and then rises once again to a maximum at position Y. So position Y, it again rises to a maximum, and we know that for a stationary wave, so let's suppose for a stationary waves, this is the baseline and this is for the stationary wave. So the points with no displacement is a node and the point with the maximum displacement is the antinode. So here we can see that maximum displacement at point A, position X and position Y. Since maximum displacement, so X and Y antinodes are produced. So at position X and Y antinodes are produced, and minimum in between them there is a minimum, that is node. The distance between X and Y is 33 cm. The speed of the sound wave is given. Which diagram could represent the CRO trace of the sound received at X? So what would be the CRO trace? So between X and Y antinodes are produced. So let's suppose this is position X. So this is position X and this is position Y. So X, X, Y. So between X and Y, if we draw this clearly, then this position is X, X, that is antinode, that is the maximum displacement, and this is Y. This has also antinode, that is the maximum displacement. So here we can see that X and Y, the distance between X and Y is half the wavelength. There is lambda by 2. So half the wavelength and the distance is 36 cm or 0.33 meter. So 33 by 100, that is 0.33 meter. So what is the value of lambda? Lambda is equal to 0.33 into 2, that is 0.66 meter. So we know the value of lambda and we have given the speed, that is v. So by using the formula v is equal to f lambda, so by using the formula v is equal to f lambda, we need to find frequency. Frequency is equal to v by lambda. So the speed is 330 and the lambda is 0.66. So the frequency is 500 Hz. And we know that frequency is equal to 1 by time period. So we know the value of frequency, that is 500. So 500 is equal to 1 by time period. So what is the value of time period? Time period is equal to 1 by 500, that is 2 into 10 to the power minus 3. So 2 into 10 to the power minus 3, that is second. So 2 into the power minus 3 second. So what would be the answer? The answer would be B, that the time base, that is for the time for one box, is 0.5. So for the complete wave, that is 1, 2, 3, 4. So for 4 box, 0.5 into 4, and since the answer is in millisecond, so we need to convert this to second, that is 10 to the power minus 3 second. So 0.5 into 4, that is 2 into 10 to the power minus 3 second. So 2 into the power minus 3 is same as 2 into the power minus 3. Therefore the correct answer is B. And you also have to remember that the distance between two antinodes is half the wavelength. So lambda by 2. The distance between adjacent two antinodes or adjacent between two nodes is half the wavelength. For example, here the adjacent two nodes is half the wavelength and the adjacent two antinodes is also half the wavelength. So the distance between adjacent antinode or adjacent node is half the wavelength. 24. Polarization is associated with certain waves. Which waves cannot be polarized? So transverse wave can be polarized while longitudinal waves cannot be polarized. So radio waves are transverse waves, so it can be polarized. Then ultraviolet, radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-ray, gamma ray. So ultraviolet and X-ray both are transverse wave, that is they are the electromagnetic waves, while sound wave is a longitudinal wave, so it cannot be polarized. 5. A guitar string is plucked. Which statement describes the resulting waves? So, which statement describes the resulting waves? Long tail waves on a string. So, for a string, we know that for a string, as the string is plucked, or if we just hit on a string, then the string, it is the initial position, and as the string is plucked, the string moves up and down like a wave. So the string moves up and down, that is up and down. So we can see that transverse waves are produced. So transverse waves are produced on the string, while as the string is plucked up, as the string is plucked. So for a guitar string, when it is plucked, sound waves are produced, and as sound waves are produced, we know that sound waves are longitudinal wave. So longitudinal wave in the air. So transverse wave on the string cause longitudinal waves in the air. So the answer is C. That the waves produced on the string, or the string vibrates up and down. Therefore, it is a transverse wave, or the transverse wave on the string that cause longitudinal wave in the air. 26. A diffraction grating with n lines per meter is used to diffract light of various wavelength lambda. So since it is a diffraction grating question, so we can use the formula d sine theta is equal to n lambda, and n lines per meter. So n lines per meter. So what is the value of d? We know that d is equal to 1 by n. So 1 by n. So this is the value of d, that is 1 by n. The graph shows the relation between the diffraction angle theta and lambda for different wavelengths in the nth order interference maxima. So it is for the nth order. Now what is the gradient of the graph? So we need to find the gradient of the graph. So what is the gradient? So this is a graph of sine theta against lambda. So, and since it is a straight line graph, so we can write the equation in the form of y is equal to mx plus c, where m is the gradient, and c is the y-intercept, and here we can see that the y-intercept is 0. So the value of c is 0, that is y is equal to mx plus 0, or just y is equal to mx. So we need to find the equation in the form of y is equal to mx, that is this equation in the form of y is equal to mx. So where y is sine theta, since it is at the y-axis, so y is sine theta. So sine theta is equal to n lambda by d. So lambda is on the x-axis, so it is the x-axis. So sine theta is equal to lambda n by d. Now here we can see that the y-axis is sine theta, so sine theta, and the x-axis is lambda, so x-axis is lambda. So m, so what is the value of m? M is equal to n by d, which is the gradient. So the gradient, or the m, is n by d. And so all the answers are in terms of n and n, so we can write d in terms of 1 by n. So n is, so the equation would be n by 1 by n, that is n. Question number 27. A stationary sound wave is formed in the air column inside a tube that is open at both the ends. So let's suppose this is our tube and the tube is open at both the ends. The stationary wave has 3 nodes. So a stationary wave is produced and the stationary wave has 3 nodes. Let's suppose if we draw a wave, this is the baseline, and the points with 0 displacement are the nodes. That is, this is one node, this is one node, this is one node. And the antinodes are the point that have maximum displacement. This is an antinode, this is an antinode, and this is an antinode. Now, for the open end, 3 nodes are produced. So, how many antinodes does it have? So, we need to find the number of antinodes. So, to find the number of antinodes, you need to know that when one complete wave is produced. Let's suppose this is a baseline and the waveform is like this. Then here we can see that one complete wave is produced, since for the 2 points, let's suppose this point and this point, one complete wave is produced because these 2 points have the same displacement from the rest position, the same direction of motion, that is this direction, and have the same speed. So here one complete wave is produced. Now for the open end, so for both the ends are open and for one end is closed and the other is open. So you have to remember that for open end, that is the open end, antinodes are produced. So this is an antinode, this is an antinode, but for the closed end, always nodes are produced. That is, this is one node, this is one node, and this is one node. So for the open end, the waves formed like this. So the first wave that is formed is lambda by 2, or has a wavelength. The wavelength that is covered is lambda by 2. And if we just complete the total wave, then this is one wavelength. So this is approximately one wavelength, and so this wave is lambda by 2. Then again, if we draw, we shorten the wave. So now the wavelength that is covered inside the tube is 1 lambda. That is, one complete wave is produced. And from this point to this point, so these 2 points have the same displacement from the rest position, the same direction of motion, that is this direction, and have the same speed. So thus one complete wave is produced, and this is one complete wave. And then for the next wave that is produced is, this is lambda, and this is lambda by 2. And if we just complete, then this is the complete version. So lambda and lambda by 2. So if we add this, then we will get 3 lambda by 2. So these are the waves that are formed from the open end. And for the closed end, one end is closed, so node, and the other end is open, so antinode. Then if we join the points, then this is first wave that is produced for the closed end. And here we can see that this is lambda by 4. That is this part of the wave is covered. So this is lambda by 4. Then for this wave, here we can see that if we just complete the wave, then this wave is completed up to, since it starts from this line, so this wave must complete up to this point. So here we can see that if we just divide the wave into 4 parts, then this is 1 part, 2, 3, 4. So 3 waves are complete in the 4 in compared to 4. That is, 3 lambda by 4 is covered. So 3 lambda by 4 is covered. So 3 lambda by 4 is the wave that is formed. Then for the next wave, at the closed end, nodes are produced, and then at the open end, antinodes are produced. And if we join the points, then this is the wave that is formed. And now we need to discuss for the open end. So for the open end, we get 3 nodes. So 3 nodes, that means there is one node, so this is wrong. There is 2 nodes, so this is not the correct answer. Then this has 1, 2, 3. So 3 nodes that matches with the given condition that is given in the question. Now for these 3 nodes, we need to find the number of antinodes. So this is one antinode, this is one antinode, this is one antinode, and this is one antinode. So in total, there are 4 antinodes. So for the open end, when the 3 nodes are produced, 4 antinodes are produced. So the number of antinode is 4. Number 28. First of all, the question is related to double slit experiment. So this is the double slit experiment, and we need to use the formula, that is lambda is equal to ax by d. So lambda is equal to ax by d, and here we can see that what is lambda? Lambda is just the wavelength of the wave, and suppose this is the lambda, that is the wavelength, this is the lambda, that is the wavelength, and so lambda is equal to a. A is the distance between the 2 double slits, so a, and x is the, this distance is called x, so this is x, that is the separation of fringes, and d is the distance from the double slit to the screen. So double slit to the screen distance is d. Now for the double slit experiment, interference fringes of separation x, so we have given that separation is x, are observed on the screen at a distance of 1 meter. So the value of d is 1 meter, and d is the distance between the double slit and the screen. From the double slit that is illuminated by yellow light of wavelength 600 nanometer. So we have given the value of lambda, at which distance from the double slit would interference fringes of the same separation x be observed when by using blue light of wavelength given. So for this question, here we have given the 2 conditions, and for the first condition we have used yellow light, and for the second condition we have used blue light. So first of all, we know that the formula, that is lambda is equal to a x by d, And to find the answer for the second question, first of all we need to relate both the questions. And since at which distance from the double slit would the interference fringes of the same separation x? So here we need to find the common thing between the two experiments, and the common thing is that they have the same separation x. Since they have the same separation, so first of all we need to make x becomes the subjective formula. There is x is equal to lambda b d by a. Then since we have made the x become the subjective formula, so for the both the conditions x is same. So x is same, that is x is equal to x. That means lambda 1 d1 a1 is equal to lambda 2 d2 a2. Now here we have given the value of lambda, and we need to find the distance d, lambda and distance 3. So what is the value of a? So here the questions does not refer to the value of a. That means the value of a is same. So the value of a is same. So lambda 1 d1 is equal to lambda 2 d2. By using this formula, we need to find the value of d2, that is for the second condition. And this is the first condition, this is the second condition. So d2 is equal to lambda 1 d1 by lambda 2. And what is the value of lambda 1? That is 600 nanometer. And since both the waves are in nanometer, so we can write the answer in terms of nanometer and they would cancel. So 600 nanometer into the distance, that is 1 by 400 nanometer. And since they are divided, so nanometer cancels with nanometer. Now 2 zeros cancels and 6 by 4. So 6 by 4 is approximately 1.5. 1.5. So the value of d2 is 1.5. So again, if we just revise, then this is the a, that is the distance between the double slits. Then this is x, that is the separation between the fringes. This is d, that is the distance between the double slit and the screen. So lambda is equal to ax by d. And for now, here for this question, we have given two conditions. So we can use the formula lambda is equal to ax by d. And here they have the same separation x. Since the value of x is same, so we can equate x, since x is same. So x for the second condition is equal to the x for the first condition. So if we make the x becomes the subjective formula, then we can solve this. So after making the x becomes the subjective formula, we equate lambda d1 by a1 is equal to lambda d2 by a2. And here the question refers to distance d and lambda and distance d, but it does not refer to a. That means the value of a is same for both the conditions. So the value of a is same, so we just cut the values. Then the lambda 1 d1 is equal to lambda 2 d2. So we need to find the distance d2, that is the distance from the double slit d2. So for d2 is equal to lambda 1 d1 by lambda 2. So we know the value of lambda 1, we know the value of d1 divided by lambda 2. So after getting our answer, we get the answer, that is 1.5 meter. Question number 29. What is the definition of potential difference across the component? So the potential difference across the component is the work done per unit charge. So work done per unit charge, or instead of work, we can also write energy per unit charge. So energy per unit charge. So the answer is A. For question number 30, the diagram shows a cell of negligible internal resistance. So the cell has negligible internal resistance connected to a switch and two resistors of resistance R and 2R. So two resistors of resistance R and 2R. The circuit also contains two ammeters X and Y. So the ammeter is X and Y. The reading on X is 4 ampere when the switch is open. So when the switch is open, the reading on X is 4 ampere. So we know the value of current. Now, what are the readings on X and Y when the switch is closed? So when the switch is closed, what are the readings on X and Y? So first of all, we need to find the values for open end, and for the closed end. So for the open end, since the end is open, so we know the value of current and we know the resistance R in terms of R. So what is the voltage? V is equal to IR. By using the formula, we can calculate the value of voltage, that is I and R. So the voltage is 4R. Voltage is 4R, or we can say that EMF provided by the battery is 4R, because here the cell has negligible internal resistance, and so the voltage gained is equal to the EMF supplied. Voltage is equal to EMF. So the EMF is 4R. So we can say that the EMF is 4R. And since the battery is same, so the EMF value is also same. That means when the switch is closed, since the battery is same, so the EMF is same. EMF, we refer this as V. So since for parallel combination, we know that the voltage is same. For series, we know that the current is same, but for parallel, the voltage is same. So the voltage is same, that is V, and the voltage is, or the EMF is 4R. So the EMF is 4R, and for the closed end, we need to first find the value of. So we know the EMF, that is 4R, and we need to find the current, that is current on resistor, current on X. So current on ammeter X. So first of all, we need to find the value of current on ammeter X, that is Ix. So first of all, to find the value of current, so we know that the EMF, or the voltage provided by the battery, is 4R. That is, the voltage is 4R, or the EMF is 4R. And what is the total resistance? So 1 by R total is equal to 1 by R1. So R1 is R, plus 1 by R2. So 2R. So R total comes to be so 2R and R. So 2R, and here this is 2. So 2 plus 1, so 3. So R total comes to be, this should be inverse, so 2R by 3. So the total resistance is 2R by 3, and the total voltage is 4R. So the total voltage of the EMF is 4R, and the total resistance is 2R by 3. By using these two values, we need to find the total current, and since the total current, so for X, we would get the value of total current that is supplied or gained by the battery. So I is equal to V by R. So the voltage is 4R by 2R by 3. So R and R cancels, and here the answer that we get is 4 into 3, that is 12 by 2, that is 6 ampere. So the total current is 6 ampere. So the total current provided by the battery is 6 ampere when the switch is closed. So we get the current that is 6 ampere, that is the total current, that is 6 ampere. Now, since we get the total current, now we need to find the current on reading on Y, that is the reading on ammeter Y, that is IY. So what is the current IY? So again, we can solve this by comparing. So since R and 2R, both the two resistors are connected in parallel, so the voltage in both the resistors is same. So voltage is same, so we can equate voltage is equal to voltage, that is voltage is equal to IR. So the current I, so or instead of just comparing, we know the total EMF value or the total voltage value. So the total voltage or the voltage across this combination is 4 volt, 4R. Because the voltage in parallel combination is same, so for this resistor the voltage is 4R. For this resistor the voltage is also 4R. So we know the voltage that is 4. So we know the value of voltage that is 4R, that is 4R, and this is also 4R. And since we know the value of voltage and the resistance is 2R, so the resistance is 2R. So we need to find the value of current. So what is current? Current is equal to V by R. So I is equal to voltage, that is 4R, by resistance, that is 2R. So R and R cancels, and the current comes to be 2 ampere. So the current that we get is 2 ampere, and the total current is 6 ampere. So the answer is C. Number 31. The IV characteristics for 4 components A, B, C and D are shown. Which component has greatest resistance? So the resistance is greatest when the potential difference across it is V1. So the potential difference is same, that is V1. So the potential difference is same, that is V1. And we need to find the greatest resistance. So we know that resistance is equal to voltage by current. And since the voltage is same, so the voltage is same, and we need to get a greater resistance. So the greatest resistance occurs when the current is the least. So in all of this option, which condition has the current that is least? So this is the highest current, and this is the least current. So the least current is in D. So when the current is least, the resistance is more. So since the current is least, so the resistance is greatest. So the answer is D. That since the current is less, so the resistance is the greatest. Question number 32. We can use the formula I is equal to NAVQ, where N is the number density, there is a number of free electrons per unit volume, A is the cross-sectional area, V is the velocity, and Q is the charge. So a cylindrical wire has a cross-sectional area A. So cross-sectional area is A. The number density of the free electron is N. The wire has a current I. So the current is I. And the free electrons have average drift velocity. That is the velocity V is V. So for the second condition, a second cylindrical wire has a cross-sectional area of 0.5 A. So the area is 0.5 A. The number density of the free electron is 2N. In this wire, the free electrons have average drift velocity of 2V. What is the current on the second wire? So we need to find the current on the second wire. So here for both the questions, the charge is same and the charge is 1.6 into 10 to the power minus 19 coulomb, that is Q. So the charge is same. That is the elementary charge Q is 1.6 into 10 to the power minus 19 coulomb. As for both the conditions, the charge is same, so we can equate Q is equal to Q. So charge is equal to, so if we make Q becomes the subjective formula, then Q is equal to I by NAV. So for the first condition, charge is equal to I by NAV. So we know the value of current, that is I. Then N, cross-sectional area is A, and the drift velocity is V. And for the second condition, we need to find the value of current. So what is the current in the second wire? So we need to find the current I2 or Ix. We consider this as X. And the number density is 2N. The cross-sectional area is 0.5 ampere. 0.5 A, that is the area. And the drift velocity is 2V. So what is the value of Ix? Ix is equal to, so first of all, to find the value of Ix, we need to simplify this. That is I by NAV is equal to Ix by 2 into 0.5, that is 1 into 2. So 2 NAV. So NAV and NAV cancels, and so Ix is equal to 2I. So the answer is 2I. That is the current in the second wire. Question number 33. An electric current is found by moving charge carriers, but is not a possible charge on the charge carrier. So we know charge is equal to 1.6 into 10 to the power minus 19 coulomb. That is the elementary charge. So this is 1.6 into 10 to the power minus 19 coulomb. So this is correct. Then if we just multiply this value by 2, so if we multiply this value by 2, then it would be 3.2 into 10 to the power minus 19 coulomb. So this can also be a charge. So this is also correct. Then if we multiply 1.6 into 10 to the power minus 19 by 3, that is multiply this with 3, then the answer is 4.8 into 10 to the power minus 19 coulomb. So the answer is 4.8 into 10 to the power minus 19 coulomb. So this is also correct. That is 4.8 into 10 to the power minus 19 coulomb. So A is also correct. But for option B, here we can see that this value and this value is not a multiple, but it is a fraction. That is 2.4 into 10 to the power minus 19 by 1.6 into 10 to the power minus 19. So if we just divide this two values, then 2.4 by 1.6, we would get 1.5. The value that we get is 1.5. So this is a fraction. Since this is a fraction, or this is not two whole numbers, so the answer B is wrong. That is, this is not the possible charge. Since for possible charge, we need to find a multiple or submultiple. But we can get a fraction, that is 1.5 or 2.5 or 1.33. Rather than, we can get our answer as 2, minus 4, 6, like this. But since it is 1.5, so this is wrong. Question number 34. Which description of Kirchhoff's first law is correct? So Kirchhoff's first law is the conservation of charge. charge. And for the Kirchhoff's second law, it is the conservation of energy. And for Kirchhoff's first law, the current entering a junction is equal to the sum of the current leaving a junction. So the current in a junction in a circuit and its consequence of the conservation of charge. So it considers the current at a junction in a circuit. So it considers the current in a junction in the circuit and its consequence of the conservation of charge. So this is correct. It considers the current in a junction in a circuit and its consequence is the conservation of energy. So conservation of energy is for the second law. Then the sum of the EMF is equal to the sum of the potential difference. This is for the second law. So the correct answer is A. Question number 35. Two resistors of resistance R and R are connected in parallel. The value of small r is less than the value of big R. So the value of small r is less. Which statement about the combined resistance of the two resistors is correct? So for parallel, we know that 1 by R total is equal to 1 by R1 plus 1 by R2. And for parallel combination, for the two resistors, when added in parallel, so we know that since both the resistors are connected in parallel, so 1 by R total is equal to 1 by R1 plus 1 by R2. And what would be the combined resistance? So this is an important question, that for combined resistance is always less than the lower resistance. So for the two resistors, the lower resistance is R. That the resistor that has the least resistance is R, small r. So the combined resistance have to be less than the least resistance. That is, it is less than small r. So for the two resistors, when connected in parallel, the combined resistance is always less than the least resistance, and the least resistance is R, or for the resistor small r, the least resistance is small r. So the combined resistance have to be less than the small r. So it is less than the small r. And if we just simplify this, then consider the two resistors, that is 3 ohm and 5 ohm. So we know that the combined resistance is always less than the least resistance. So the least resistance is 3 ohm. That means the combined resistance have to be less than 3 ohm. So combined resistance have to be less than 3 ohm. That is, if we just calculate the combined resistance, 1 by R total is equal to 1 by 3 plus 1 by 5. So the combined resistance comes to be 1 by 3 plus 1 by 5. And if we just inverse this, then the combined resistance comes to be 1.875. So here we can see that the combined resistance, that is 1.875, is less than the least resistance, that is 3 ohm. So combined resistance is less than the least resistance, that is 3 ohm. So here it is less than R. So you have to remember that the combined resistance is always less than the least resistance. So the least resistance is smaller, so the combined resistance have to be less than the least resistance. And this is for parallel combination. Number 36. The diagram shows four identical resistors connected in a circuit. So the resistors are identical. That means they have the same resistance R. So this is the resistance R, this is the resistance R, R and R. Since they are identical resistor, which resistor dissipates the most power? So we know that power is equal to VI. Also we know that power is equal to I square R and V square by R. And since the resistors are identical, so they have the same resistance. So all the resistors have the same resistance. So we know the value of resistance and resistance. There is a resistance is same. And here we know that for the circuit, the current entering a junction is equal to the sum of the current leaving the same junction. So current entering is equal to current leaving. It is I is equal to I, and this current is divided into I1 and I2. So we know that current I is equal to I1 plus I2. There is the current in this junction plus the current in this junction. So the current is added and the current is I. So that means the total current or the highest current is in option A. So by using the formula, power is equal to I square R. So power is equal to I square R. So all the resistors have the same resistance. That is, all are identical. So the resistance is same. So power is equal to So all the resistors are identical. So the resistance is same. Now, one which has the highest current would have the highest power. So here we know that the current highest in option A, and this current I is divided into B, C and D. So the highest current is in option A. So the power is also highest for option A. Number 37. Nuclide X with proton number Z, undergoes beta plus decay to form nuclide Y. Beta plus decay to form nuclide Y. The decay may be represented by the equation shown. What is the proton number of Y and which particle is represented by the symbol Z? So here we can see that this is beta plus particle or positron. So you have to remember that with positron neutrino is emitted, and with electron antineutrino is emitted. So electron and antineutrino. So with electron antineutrino is emitted, and with positron neutrino is emitted. So since positron is emitted, so neutrino is emitted. So the particle W is neutrino. And what is the proton number? So beta plus particle is emitted. So beta plus particle is also a proton. So since a proton is emitted, so the proton number is decreased by 1. So the answer is B. That since beta plus particle is emitted, so a proton is emitted, so the proton number must decrease by 1 for Y. And since positron is emitted, so that with positron neutrino is emitted. So the answer is B. Particles are made up of leptons and hadrons. So leptons and hadrons. Now hadrons are made up of quark. So since they are made up of quark, so they are affected by strong nuclear force. But leptons are not made up of quark. Since they are not made up of quark, so they are not affected by strong nuclear force. So hadrons are made up of quark, so they are affected by strong nuclear force. But leptons are not made up of quark, so they are not affected by strong nuclear force. And for hadrons are divided into baryons and mesons. So baryons are made up of 3 quark. So suppose proton and neutron. So proton and neutron are baryon. And since they are baryon, so they are made up of 3 quark. There is up and down quark, and up down quark. So proton, it is up and down quark, and for neutrons it is up down quark. And meson is made up of 2 quark, that is matter or antimatter. Meson is made up of 2 quark, matter or antimatter. And for leptons, since the leptons are not made up of quark, so an example of lepton is electron, neutrino, or so antineutrino. Lepton is neutrino or antineutrino or electron. These are the leptons. And for quark, you have to remember that for up, top, and charm quark, so for all the quark, they have a mass of U by 3. That is U by 3, U by 3, U by 3. But for up, top, and charm, they have a charge of plus 2 by 3e. While for down, strange, and bottom quark, they have a charge of negative 1 by 3e. So we have discussed the charge and baryons, protons and neutrons, leptons, electrons, neutrinos or antineutrinos. For question number 38, which fundamental particles form hadron? So hadrons are the example. The examples of hadrons are protons and neutrons. So these are the examples. But which fundamental particle form a hadron? So which fundamental particle form a hadron? So hadrons are made up of quark. That is quark. So the answer is D. That quarks form hadron. So quarks are the fundamental particle that form hadron. Question number 39. The unstable nucleus X decays through a sequence of emission of alpha and beta minus particle to form a stable nuclide Y. How many alpha and beta minus particles are emitted during this decay process? So when beta minus particles are emitted, neutron changes to a proton. This is the equation. Neutron changes to a proton, and alpha particle are made up of 4 nucleon, and the nucleon is the total number of proton plus neutron and 2 protons. So X, that is X 218 and 84 decays to form Y 210. So this is 210 and 83. 210 and 83. So here we can see that the nucleon number decreased from 218 to 210. so the nuclear number is decreased by 8. Since the nuclear number is decreased by 8, so nuclear number is decreased by 8. And since here for the beta decay, beta particles have 0 nucleon. Since it has 0 nucleon, so it is not affected by beta particle, but for alpha particle it has 4 nucleon. So this decrease is affected by alpha particle. So since the number is decreased by 8 and alpha particle contains 4 nucleon, so 4 into 2 is 8. That means 2 alpha particles are emitted. 2, 4, 2. Since 2 alpha particles are emitted, so here you can see that 2 into 4, that is 8. So 8 nucleons are emitted. So the alpha particle is emitted is 2. And when 2 alpha particles are emitted, so 218, 84, X. X decays to form Y, 210 and 83. So we know that 2 alpha particles are emitted. So 2 alpha particles are emitted. And for 2 alpha particles, so 2 alpha, and alpha particle has a nuclear number of 4 and has a proton number of 2. So what is the change in proton number? So here we can say the nuclear number is balanced. So 218 is equal to 210 and 2 into 4, that is 8. So this is balanced. Now what is the decrease in proton number? So 84 proton is changing to 83 plus 2 into 2, that is 4. So 87. So 84 to 87. That means here we can see that the proton number is, this is a proton number, and here the proton number has increased by 3. So the proton number has increased by 3. And since the number of protons are increased, so the number of proton is increased by 3. That means 3 beta decay occurs. So 3 beta decay occurs according to the equation. When 1 beta decay occurs, proton number is increased by 1. And when the proton number is increased by 3, so since the proton number is increased by 3, so 3 beta decay must occur. So the beta decay that occurs is 3 when 3 protons are emitted. So the answer is C. Question number 14. Which statement about radioactive decay is correct? Neutrinos are always emitted during alpha decay. So neutrinos are emitted when beta decay, not alpha decay. So alpha particles are emitted from a radioactive sample have a continuous range of kinetic energy. This is wrong. Alpha particles have discrete or same amount of kinetic energy. But for beta minus particle, they have a continuous range of energy. So the answer C is correct. That when beta minus particles are emitted from a radioactive sample, they have a continuous range of kinetic energy. Yes, this statement is correct. The proton number of a nucleus decreases by 4 when alpha decay occurs, or when it undergoes alpha decay. So for alpha decay, since alpha particles are emitted, so alpha particle contains 2 protons. So the proton number must decrease by 2, not 4. So proton number must decrease by 2, therefore this is wrong. And the correct answer is C, that beta particles have a continuous range of energy. And why beta particles have continuous range of energy? Because with beta particle, neutrinos or antineutrinos are emitted, and so the energy is shared between beta particle and antineutrino or neutrino. Therefore beta particles have continuous range of energy. Since the energy is shared, so they have a continuous range of energy.